Assalamualaikum and good afternoon. Today we will continue our topic electrostatic. Electrostatic is the branch of physics studies behavior of the electric charges at rest. It deals with phenomena that arise from interaction between stationary electric charge, including attraction or repulsing between them, the electric field they create, and the electric potential energy associated with their configuration. So in this electrostatic, we will study the interaction between static electric charges, whether it attract or repulsion. The application of electrostatic include inkjet printers, photocopiers, and spray printing. This is the chapter outline of this topic. So we will cover Maxwell equation, charge distribution, and Coulomb law. Maxwell equation. So Maxwell equation are a set of 4 fundamental equations that describe the behavior of electrics and magnetic field. So this is just the combination of 4 fundamental equations is from Gauss law, Faraday's law, and Ampere's circuit law. So the combination of that 3 law to produce 4 equations. Okay, this one is a Maxwell equation. We have 4 equations. The Maxwell equation is curl dot product and also curl cross product to electric and magnetic. And also cross product electric and magnetic. This one is we want to study the behavior of electromagnetic fields. There are two components in electromagnetic field. We have electric and magnetic. So we deal with dot product and cross product. Cross product sometimes we call curl, C-U-R-L, dot product, divergence. Okay, this one is dot product to D. This D is electric field density. Sometimes they wrote as dot E. E is electric field intensity. So this one, in this case, we write as D. D is electric flux density, which is equal to epsilon times E. Epsilon is electrical permittivity of the material. D is equal to epsilon E. So this equation also can be written as dot E equal to rho V over epsilon. The Maxwell equation is a combination from two Gauss law. This one Gauss law. This one also Gauss law. This one is Faraday's law. This one is Ampere's circuit law. It will become Ampere-Maxwell equation. So this is 4 from this combination of 4 law. Okay, first is divergence or dot product, Gauss law. Okay, Gauss law for electric fields also can be written as dot D equal to rho V, where D is equal to epsilon E. So in this case, we just write this. This one is a dot product. Del dot products means that that we learned before. When we do del dot product, the output will be a scalar. Okay. This one is vector field of E, electric field in vector field. Then when del dot vector, the output will be scalar. So there's no direction, just a scalar unit. Okay, rho is electric charge volume density. Epsilon is electric permittivity of free space, also called dielectric constant. All right. Okay, divergence or dot product, Gauss law for electric fields. So from this equation, we can see that there are 3 types of output of the dot product. First is greater than 0. Second is less than 0. Third one is equal to 0. This value is positive or negative or 0. So study the behavior of electric fields at this location. What we can see is the input of electric field and output electric field is equal. Then for this case, at this place, our output will become 0. This one. If you study here, you can see that all the arrow go into this circle. So in this case, there will be negative value of the output. So in this case, the what we call the divergence, not divergent, it's convergence. Converge. Converge. Our field is converge. Or we can say sync. All the arrow go into one point. So this one is convergence, sync. For negative value. Okay, third scenario is, in this case, what we can see is all the arrow go out from this circle. Or we can say this divergence. Diverge. This one is for positive value of the product. Our output is positive, so means that our system is divergence. Okay. So the behavior of the electric field, the electric field is diverse. For this one, diverse. For second one, converge. For third one, neutral. The total input is equal to total output. Right? This one is for the first equation of Maxwell equation. Next is we go to this one, Gauss law also. Oh, sorry. Gauss law for magnetic field. The first one is for electric field. This one, second one is for magnetic field. B is magnetic field. E is electric field. So for magnetic field, this one is a dot product of magnetic field. Magnetic field is in vector, is equal to 0, always 0 for magnetic field. Why? Always 0. For electric field, they have positive, negative, and 0. However, for magnetic field, always 0. Why? Okay, we know that for magnetic field, this is a magnet. Magnet, they have south pole and north pole. Even if we break it, this is magnet, north and south. When we break it into two, it will become north and south. When we break it one more, we become north and south. We break it, north and south. So for magnet, there is always two polarity, north and south, always north and south, even we break into small pieces. So we know that The magnetic field is from north to south. Here we can see that all the arrow go into and leaving is same. And we do here also same. We do here same. We do here same. Same. So at any location we do dot product, we do divergent or dot product, there will be same input and same output. Flowing in and flowing out means that at any location the dot product will be 0. This is the second equation of the Maxwell equation, which they use Gauss law. Magnetic, the previous one is Gauss law for electric field, and then second one is Gauss law for magnetic field. The third equation is Faraday's law. Magnetic fields changing with time produce electric field. I believe you already learned in your first year course, I think transformer. I think you learned already transformer and electromagnetism. So let's say we have a magnet coil. So this magnet we can move in and move out. This coil, so magnet we have their own magnetic field surrounding north and south magnetic field. So when this magnet we put inside the coil, this coil will cut the magnetic field. And the needle will be moved. Means that they show the existing of electric field. So changing magnetic field means that we change when we move magnet inside the coil, means that we change the magnetic fields. So this changing magnetic field, changing with time, will produce electric field. Changing with time means that they have a speed. We can move faster or slower. When we move fast, it will change very fast. Then it will produce higher electric field. When we move slow, it will low electric fields. Okay, this we call EMF induced. As a third equation for the Maxwell equation for this law, cross product of E will produce. So this one is cross product of E will produce by changing of magnetic field. Okay, dt. Dt means that we deal with time. So we deal with time means changing with time. Magnetic field changing with time, it will produce electric field. Okay, this negative is give the direction of vector. The next is from Ampere's Maxwell law. Say the changing of electric field produce magnetic field. Okay, this is continue from the Faraday's law. Faraday's law say changing magnetic field produce electric field. Ampere's second law say that changing electric field can produce magnetic field. The combination of magnetic field and curl of electric field, Faraday's law and Ampere's second law. Okay, this changing magnetic field produce changing electric field, and the changing electric field produce and the changing magnetic field. So this cycle will continue, propagate through space. So by using this combination, we can propagate electromagnetic wave through space. So for static case, means that static case dt over dt means that we consider there is no changing of time. So we consider dt equal to 0. Then the Maxwell equation is reduced to, we can split the two categories, electrostatic and magnetostatic. Electrostatic is for electric field. Static means that t equal to 0. And then is magnetostatic is for magnet. This one is for magnet. That is for electrostatic. So for this chapter, we will focus on electrostatic. electrostatic. So first we will discuss on the electric charge distribution, and Coulomb's law. Okay, what is electric charge? Okay, before we go to electric charge, we just review what is atom. Atoms are made of positive charge in the nucleus surrounded by a cloud of tiny electrons. This one is nucleus. Nucleus is a combination of neutron and proton. That is nucleus. And electron surrounded it. This one electron. Electron in their electron valence. The atoms are normally neutral, meaning that they have same number of proton and neutron. So neutral, the amount is E equal to 1.602 times 10 minus 19. For proton, positive here. For electron, negative. Just put negative here. For electron. Okay, question here. Which type of charge is easiest to remove from atom? You can see here, proton is attached at neutron. Electron is surrounding at their orbit, electron. So to answer this question, which type of charge is easiest to remove? Proton or electron? The answer is electron, because the distance of electron is far away from nucleus. So this is the easiest way to remove electron compared to proton. So how to remove it? How to remove electron? We can use energy to electron. Some sort of energy is we can use the heat to electron, and then electron can move away from this atom. So what happened if electron move away from this atom? When we remove electron, this
positive charge.
this atom will less electron. The atom will be extra proton. So our atom will become positive atom. Okay, positive here. Let's say this is electron move away. So our atom will become positive charge particles. So now, how to make it become negative? To make our atom become positive, we just remove electron. Can we remove proton? If we remove electron, it will become positive. If we cannot remove proton, how to make it charge negative? So by adding extra electron, we add electron from outside. So our atom will become negative charge due to they have extra electron. Fundamental charge. For one electron, there will be 1.6 times 10 power of 19, minus 19. Unit is coulomb. There are two types of charge: positive charge, shortage of electron, and negative charge, excess of electron. Electric charge. How to add or remove electron? So we can use triboelectric series. Okay, tribo means we are rubbing. If two materials are rubbed together, electron will be transferred from the material higher in table. Okay, we have table here. Let's say we take silk and glass. Electron from glass will be transferred to silk. So our glass will become positive charge. The number two, plastic with wool. Okay, let's say we put plastic wool, electron are transferred to the rod. Okay, electron from the wool will be transferred to our rod. So this will become negative charge. First, positive charge, then negative charge. Conservation of charge. Electric charge can be neither created or destroyed. It can be separated and move around. But the net charge of the isolated system must remain constant. Okay, key initial to Q final. Okay, this example, we wrap a plastic rod with wool, then electron will transfer to the rod. Electron from wool transfer to electrode. So electrode will become extra electron. Okay, electron becomes electron, it will become positive, a negative charge. Next is charge distribution. So distribution of charge. Charge symbol is Q for charge. Say this is just positive. Charge may be distributed over volume, a surface, or a line. So we have line, just one line, is surface, and also volume. That's 3D. This is just line, 1D. This is 2D. Line charge density. So to calculate line charge density, we consider, okay, let's say we have line here. The total charge along a line. This is a line. So total charge Q along the line. How to calculate it? We know that line charge density, rho L, is equal to total charge over length of line. Length of line. Okay, this line. So total charge, let's consider just small location. For example, this here, the length is here. This is just small length, and we can consider as dl, small length. And Q will be here, as a dq. Rho L is equal to dq over dl. So what is dq? Dq equal to rho L dl. This q is equal to integrate dq and also integrate rho L dl. So this one. Okay, total charge along line is equal to, we integrate rho L dl. Total charge along line. Next one is surface density. So we have, let's say we have surface. We consider just small part of the surface. For example, let's say you put here as ds, surface. And also there will be dq here. Surface charge density rho surface is equal to total charge over area of surface. So we can consider just small part only. Okay, this part, surface at this part as a ds, rho s will be equal to dq over ds. dq will be equal to rho s ds. Then we integrate here. So to get q, just integrate here. Q will be equal to rho s ds. One is the formula for total charge on the surface. Next is density, charge density or volume. Okay, we just consider small part of volume, dV. And there will be dq here. Rho v is equal to total charge over total volume. So we consider just small part, rho v equal to dq over dv. dv equal to, sorry, dq equal to rho v dv. To find q, we just integrate here and integrate here. So they will be, q will be equal to integration of rho v dv. So unit is coulomb, total charge in volume V. Example, calculate the total charge Q contained in a cylindrical tube of charge oriented along Z axis. The line charge density is rho L equal to 2Z, where Z is the distance in meter from bottom end of tube. The tube length is 10 centimeter. Okay, 0 here, 10 centimeter, Z, so rho L here. So calculate total charge. So given is rho L, rho line, and length is 10 centimeter. So using the formula for line charge density, so total charge along line, this formula, Q equal to rho L dl. Okay, this one, dz. Due to we use this one is length. Okay, dz is from 0, we integrate from 0. Q equal to rho L dz from 0 to 10 centimeter. 10 centimeter means that 0.1. Just replace this one is 2z and dz. So 2z dz. 2z will become z power of 2. And then 0.1 minus 1 equal to 0.1 minus 0 equal to 0.01 coulomb. This one is total charge for cylindrical tube. Example number 2, find the total charge over the volume. We deal with volume. Rho V equal to 5e power of minus 10 power 5 rho Z micro coulomb meter square. We just substitute. We did learn about volume of the cylinder. So we have R here, and we have phi and Z. R, phi, and Z. So for this case, phi is equal to cylinder equal to 2 pi. This angle 2 pi or 360 degree. Rho, this one is from 0. This one is 1 cm. So means that we consider from 0 to 1. 0 to 1 cm. For Z is 4 cm and 2 cm. So from 2 to 4. This one is Z. Z from 2 cm to 4 cm. So we integrate from 0.02 to 0.04. Phi, we integrate from 0 to 2 pi. 0 to 2 pi. Rho R, radius of the cylinder. The radius of cylinder is from 0 to 1 cm. So so from 0 to 0.01. Then we just using this equation and we integrate it. We got this value. Like this current densities. Current density is defined as J is equal to rho V U. The density, U means that velocity of moving charge, time rho. So the other type of current, convection and conduction current. Okay, convection current generated by actual movement of electrical charge. Okay, the last one is Coulomb's law. Coulomb's law is a fundamental principle in electromagnetism that describes the electrostatic interaction between electric charge, the interaction between more than two charge. Let's say we have Q1, Q2. So there will be interact between Q1 and Q2, whether it will attach, it will or repel. So depend on the type of Q. Coulomb law states that the magnitude of electrostatic force between 2 point charges is directly proportional to the product of their charges, inversely proportional to the square of the distance between them. Mathematically can be expressed as F means the force equal to K, Q1, Q2 over R squared. Let's say we have Q1 here, Q2 here. So the distance is equal to R. So force is equal to Q1 times Q2 over R squared, time constant here. Force equal to charge at Q1 times charge at Q2 divided by the distance square times K. K is equal to this value. K equal to 1 over 4 pi epsilon naught. Epsilon naught is equal to 8.854 times 10 minus 12. Force at this part. Force at Q2 due to Q1. Due to charge at Q1. That is Coulomb's law at the P. So the distance between P and Q is R. Point here times Q, K. Constant. So actually E at this point, E at P, E here, E at P is equal to, direction is R. So this is direction of vector R here. So means that this P will be moved here. In this case, I think we use positive and also positive here. Positive and positive will be repelled here. If we use negative here, direction of will be go here. Direction of P will be go to attract. This one if you use negative charge. For in this example, we use positive charge, so it will repel here. Okay, force equal to K Q1 Q2 over R squared. In this case, this one is E. E equal to F over Q. So you just divide this Q. That's why our equation will become just one Q. E equal to F over Q. So then we will divide this Q. So it will become K Q over R squared. K equal to 1 over 4 pi epsilon naught. This is Coulomb's law. Force acting on charge in the presence of electric field at a given point in space, F equal to QE. Okay, E equal to F over Q. F is force acting on charge Q when the charge is placed at a given point in space. The electric field is maybe due to the single charge or distribution of many charge. The unit is for F, force is newtons and Q is coulombs due to Coulomb's law. Okay, I think that's all for today. See you in this Friday, face to face. Thank you very much.